So we just discussed that the projection vector. Okay, let's take a minute. So before we go much into the solution, right? I want you to think of this question here. There are 4 cases. Case 1, the wind is parallel to aircraft. Case 2, the wind is perpendicular to aircraft. Case 3, the wind is anti-parallel to aircraft. And case 4, the wind is inclined at some angle theta to the aircraft. The question here is, in which of these cases would the aircraft benefit the maximum? Would benefit the maximum. So pause the solution here. Write down these cases. Try to solve it numerically and then make sense out of it. Okay? Please, it's a very humble request. Please do think of this. If you've done it, I hope you have. So we just discussed that the component of vector A along vector V will be the magnitude of projection vector, which is projection on vector B by vector A given by vector A dot vector B by magnitude of vector B. Okay, and we did also find out the projection of these 2 vectors. Now let's try to see the concept of wind help in aircraft, which literally means how much is the wind contributing towards the movement of aircraft. So, when a plane is flying, it wants to move in a specific direction, say east. Now, east, specifically I mean along the x-axis or along plus I cap. Okay? But wind might blow from any direction. And depending on that direction, it might be either helping or slowing or just pushing the flight sideways. How much is the wind helping or hurting the plane in its desired direction? This contribution, helping or hurting the plane of the wind by the wind, is what we call as wind help. In physics, this wind help is the projection of wind vector on the plane's direction vector, or in other words, is the component of wind along the flight's path. It's very important. If you are making note of this, please make sure you don't skip this sentence in particular and maybe the whole of this. Okay? So if we define 2 vectors, this is wrong. This should be vector W and vector D. So vector W represents the wind vector. Vector D represents the direction of plane or the path of plane. In which case, wind help will be vector D dot vector D by magnitude of vector D. What is magnitude of vector D? It is D. What is W vector D dot vector D? Magnitude of vector W, which is W, magnitude of vector D, which is D cos theta. So D by D is 1. Therefore, we get wind help is equal to W cos theta. Now, when wind help is equal to W cos theta, theta plays a very important role between the effect of wind and the actual path of the aircraft. What is theta? Let me just make sure that you get the concept clear. So this is wind, and this is the path of the aircraft, and this angle here is theta. Okay? Now, if you have done the 4 cases on your own, this might help you a lot. Okay? So we have case 1, which is otherwise called as tailwind, or wind in the same direction of the aircraft. So this is the wind vector, and maybe this here is the displacement vector of the aircraft. So both the wind and the aircraft are in the same direction, which means theta is equal to 0 in this case, which means theta is equal to 0 in this case. And therefore, what is cos theta? Cos theta is cos 0, 1. So cos theta is 1. So WA by A or WD by D becomes just W, right? So wind help now is numerically equal to W plus W. What does it mean? It means that the plane moves faster because it is getting a push. The ground speed increases. I'm not going much into what is ground speed because we have a couple of questions based on relative velocity, and then things will become more clear regarding ground speed. Now, since the plane is moving faster, not alone by virtue of pumping more fuel and burning it, rather because it is being pushed by the wind, what happens? Less fuel is needed to attain the same speed. Okay? And of course, when it is traveling faster, it will arrive early. So that is case 1, tailwind. Now, what is case 2? Headwind, or in other words, the wind is in the opposite direction. Wind is in the opposite direction of the aircraft. So aircraft is heading towards east. So aircraft is heading towards east, that is I cap, and wind is acting towards the left, which is negative I cap. And therefore, the angle between them is theta is equal to 180 degree. And when theta is 180 degree, what is cos 180? Cos theta is cos 180, which is minus 1. So helped by the wind is WA cos theta by cos theta, A or D. A by A is 1, W cos theta is minus 1, it is minus W. Therefore, wind help is negative W and is therefore the maximum negative projection. What does it mean? It further means that the plane will slow down irrespective of how hard it's trying to push. The ground speed will decrease and eventually more fuel will be needed to push the aircraft to resist this wind here. Now imagine you are cycling into a strong wind. The same scenario here. As a result of which, the arrival will be delayed. In contrast to case 1, where we'll arrive early. Okay? Now let's see what is case 3. Case 3 gives us wind vector like this. Sorry, displacement vector like this. Wind vector, maybe I should be more precise. So plus I cap is the wind vector. Plus j cap is the vector of wind, and therefore the angle between them is theta is equal to 90. When theta is equal to 90, cos 90 is 0. Therefore, wind help is W into A by cos into A cos 90. Cos 90 is 0. Therefore, wind help is 0, which means the projection is 0 projection. What does it mean? It means that the plane will drift. It will drift like this. Pilot must adjust heading, which is otherwise called as the crab angle, or is the process called as crabbing the plane. To give you an analogy, this would resemble what happens when you're walking straight while being nudged sideways. So maybe you're trying to walk like this, but when someone is consistently pushing you, what happens is you take this path like this, an inclined path. The plane is drifting away from the original path. Which condition? When the wind is perpendicular to the path of aircraft. Okay? Now, case 4, when the wind is at 60 degree, this time, this is the vector wind, and this is the vector of flight's path, and the angle between these vectors is 60 degree. When theta is 60 degree, what is cos 60? 1 by 2. Therefore, what is wind help? It is wind into, say, displacement by displacement into cos theta. D by D is 1. W cos theta. Cos theta is 1 by 2. So it becomes W by 2. So W by 2. In other words, it's half the value of W. which means only half of the wind will help the plane to increase its speed. The other half will push it sideways. So the wind here is playing two roles. 50 percentage of the wind will help the plane. The rest 50 percentage will drift it. Hope that makes sense. Okay. Right. Now, so we did compare four different cases. One, wind is fully aligned, 0%. Angle is 0 degree, 100% helpful. Wind is opposite, angle is 180 degree, 100% harmful. Wind is at 90, the aircraft is drifting towards. And if the wind is at 60, you can fill out the rest. Well, this is what I want you to write as an interpretation of the four cases that we discussed earlier. Okay? Maybe you can just make a note of this as well. Not to say that, well, see, to be frank, I'm not expecting any question as an application of component along vector A, but B, but given it's not the JEE mains is not that unpredictable. But let's try to be as safe as possible, and let's try to just understand that yes, there is a very slight possibility that this might a question might pop up from this concept. Maybe not directly the wind and the aircraft, maybe something else. But then going through this explanation would definitely help you to solve those. Statement 1, statement 2, or assertion reasoning, maybe. We don't know. We never know, actually. Right? Okay. So if you're making a note of this table, make sure that you do write down this one. Wind is parallel, wind is opposite, wind is at perpendicular. These three are not actually. You can skip these three. This is application of theta. But these three are really important. 1, 2, 3. 0, 180, and 90. Okay? Right. So that is what I wanted to share with you. Now, another application. Well, that's not an application of projection of vectors. It's just an alternative view of vectors that we use most commonly in laws of motion. Let's go through that.